In today's video, we're going to look at a problem involving two coordinates, and I want to just try and work out as much as I can from these two coordinates as possible. And I think there are sort of 5-6 main things which we should be able to get out of by the end of this video, but we can do with any coordinates. So, first thing we're going to do, I've got these two coordinates. Why don't I just find the difference between them? Find the length of this line which connects the two coordinates. I think that would generally be the first thing that I'd want to know. And what we should notice is that just by looking at this, if we just create a right angle triangle connecting A and B, we could work out the length. And this is generally the way we do this. So the length is going to be equal to, well, it's the square root. And to get from A to B, it's just the difference in the x coordinates squared plus the difference in the y coordinate squared. So x2 minus x1 squared plus y2 minus y1 squared. And for our scenario, that's just going to be the square root of, well, it's 2 squared and 4 squared. 2 squared plus 4 squared. Well, 4 would be the x, but you get the idea. So it's a square root of 20, which we know is 2 root 5. Okay, nothing too new here, just a bit of Pythagoras. What else do we want to know? I would argue we'd want to know what that line would be if we extended that segment into a full line for A. What would that look like? So, if I just went like this, what would be the equation of that line? So, looking at AB, I want to know the equation of a line that connects AB. So, what do I need to know for a line? Well, I need to know the gradient, and I need to know the point on a line. So, the gradient I can work out. Luckily, we looked at this earlier today. The gradient is equal to, well, it's the difference in our y coordinates, so y2 subtract y1, all divided by our difference in our x coordinates, x2 subtract x1. So for our scenario, y coordinates are 6 and 4, so 6 subtract 4 over our x coordinates are negative 3, negative 1. So we end up with something, what's that going to give us? 2 over negative 4, so negative a half. I put the negative in straight away because if we just look at this line, we can see that it's going to be negative. So I knew it was negative, and this has just confirmed that. Okay. So looking at this and thinking about how we can rearrange this to give the equation of a line, we get y subtract y1 is equal to m lots of x subtract x1, and this is generally the form that we're going to use whenever we want to look at the equation of a line, because all we need is the gradient and a point on the line. So, looking at this, I've got the gradient as negative a half, so I can just put that in here for m. And a point on the line, let me just use point A, which is 1, 4. So, y subtract y1, don't make a silly mistake here, we need a y coordinate, which is 4, is equal to x subtract x1, and our x coordinate is 1. Expanding this by multiplying everything by 2, it's going to give me 2y subtract 8 is equal to the negative of x take away 1. So 2y subtract 8 is equal to x plus 1. And sometimes they might want us to write it in the form of, I'll write it up here so we can see it, ax plus by plus c is equal to 0. So if that is the case, all we do is just rearrange it to be equal to 0. Sorry, so it's minus x, isn't it? That makes sense, bringing that in. So it's 2y plus x subtract 9 is equal to 0. Okay, let me just bring these together and bring this over here. Lovely, so that's the equation of our line for B to A. What else will we want to know? Okay, the next thing to think about is something called the perpendicular bisector. So, what does that mean? Well, perpendicular, it means we're going to be looking at a right angle, and we want it to be a right angle to this line going, hopefully on the video it'll look how's it going to look? Like that. Okay, it's flipped for me, but it's going to look like that, and I want the perpendicular bisector, which is going to go across. But what does the bisector mean? Where am I going to put that? Well, bisecting something means cutting it exactly in half. So looking at the points B and A, if I want to bisect them, I need to find the midpoint of them. So I'm just going to quickly work out the midpoint. And to find the midpoint, it's just the average of the coordinates. Well, the average of the x coordinates, you add them together and halve it. So 1 plus -3, -2, halved is -1. And the average of the y coordinates, 4 and 6, is going to give me 5. If you need a formula, hopefully we should be able to do that straight away, but the midpoint is x1 plus x2 over 2 and y1 plus y2 over 2. Okay, so we've got a midpoint. I'm just going to highlight that in brown again because I think that's important. What else do I need to know? Well, I've got the midpoint, so I'm just going to plot that on here. And I want to know the perpendicular bisector, so I need to know something that looks like, let's say it looks like this. I'm just going to move it so it goes through. Okay, and well, what can I do here? What's the relationship going to be between the gradient of the original line A to B or B to A and this new line, the perpendicular bisector? Well, the gradients are going to have a negative reciprocal relationship. So, what does that mean? Well, the gradient of my line A to B was -1/2, so I could just simply write down that the gradient of my new line, the gradient of my perpendicular line, so I'm going to use subscript P, is the negative reciprocal of that, so therefore that's going to be equal to, well, it's just +2, isn't it? Okay, so from here, what's the next logical thing for me to do? Well, I've got a point and I've got a gradient now, so the next logical thing would be to, well, using this formula, work out the equation of the perpendicular bisector. So I'm going to go straight ahead and do that. Y subtract y1 is equal to m lots of x subtract x1. And now I need to be careful, what are my y and x values going to be? Well, it's going to be any value on this line, but I only know one of them, and that's this point here, which is the midpoint, which we know is -1/5. So, being careful with the negatives, y subtract 5 is equal to 2 lots of x subtract -1, which is +1. Rearranging this, making this look a bit nicer. Again, thinking about this form of ax plus by plus c equals 0 in the top right corner. What we're going to get? Well, y subtract 5 is equal to 2x plus 2. Taking everything across, y subtract 2x, take away 7 is equal to 0. And I would argue that this is all of the important information that we need for this question. So, what I would encourage you to do is just pick two coordinates and work out some of the interesting facts about them. So work out what the length of the segment would be, maybe work out the equation of a line, work out the midpoint, and work out the perpendicular bisector. And from there, once you've done this 3 or 4 times, you should be well on your way to being confident with straight lines. So, thank you for watching. If you've got any questions, please let me know. Please drop me a message on Teams or email me, but I will see you in the next video.